Welcome back, everybody. Let's look at another example of particle kinetics. To test a solid rocket booster, a rocket test sled is being used whose mass is 1,000 kilogram. It is generally known that the force developed as time changes is going to be a quadratic function of time given by this equation, F equal to some constant a plus bt minus ct squared. If the rocket has an initial thrust of 10 kilonewtons when it begins its motion and reaches a speed of 150 meters per second, traveling a distance of 700 meters over 10 seconds, what are constants A, B, and C for the rocket? So let's, regardless of what is the detail of the situation, remember that we typically want to follow the same procedure for particle kinematics. I should say particle kinetics, sorry, which is draw a free body equation, then apply equations of motion. If there are more than two unknowns in a two-dimensional case, then we can also use equations of kinematics along with the initial conditions to solve for the desired unknown. So let's draw a free body diagram here. Suppose that this is the rocket. Let's say the forces acting on it, weight due to its mass. So I write mg in general. There's a supporting force by the track pushing up, I call it N, and then the propulsive force which changes with time, F of t, and this force is a given quadratic function equals to, let's say, ma in x direction, of course. So if I write the equation of motion in x direction, I basically have f of t equals to 1000 a. But observe that initially we have let's see, it says it has an initial thrust of 10 kilonewtons. This means at time equal to 0, I have 10,000 Newton equal to ma. M is 1,000 times a. Therefore, acceleration can be determined at time t equal to 0. Observe that because the force is a variable function of time and the mass is constant, acceleration a is also a variable function of time. So this is acceleration at time t equal to 0, but if I take the general equation F equal to ma, I can solve for acceleration a if I divide the force function by the mass. So the force function was, let's see, a plus bt minus ct squared, but I'm dividing both sides by m, so I actually have m in the denominator for every term on the right side as well. So note that from the first equation that I wrote, if I plug for time t equal to 0, this is the original equation. So let's write it down. When t equals to 0, the initial propulsive force is 10 kilonewtons. Therefore, this constant capital A, not to be confused with lowercase a, which is acceleration, capital A turns out to be 10,000, sorry. So let's continue with the acceleration equation, lowercase a. If I divide, let's see, every term by mass of 1000, then I have acceleration equal to 10,000 over 1000 is 10 plus b over 1000 t minus c over 1000 t squared. So I have at this point acceleration as the function of time. Well, if you recall the general equations of kinematics, velocity can be found if I integrate this equation. So let's do so. Then v of t is integral of this equation, which gives me 10t plus bt squared over 2, but I have 1000 in the denominator, so that becomes 2000. Then I have minus ct cube over 3, which gives me ct cube over 3 times 1000, or 3000, plus initial velocity, which if we take it to be 0 will give us this equation. Then recall that velocity is derivative of position, so if I take one more integral from this, I can write the position as a function of time. So s of t equals to integral of 10, t is 10t squared over 2, which is 5t squared, plus b t cube over 3, which gives me 6000 in the denominator, minus c t to the 4th power over 4 times 3000 is 12,000, plus initial position s naught, which I take to be 0. Observe that at this point I still have two unknowns, capital B and capital letter C. Two unknowns, two equations, two initial conditions. If I continue with using the initial conditions, I can basically do the algebra and solve two equations for two unknowns. So let's do that. We know that after 10 seconds, velocity is 150 meters per second, so I write v of 10, which is 150, equals to, let's call this equation 1 and call that equation 2. I plug a 10 second in equation 1, so I have 10 times 10 plus b 10 squared over 2000 minus c 10 cube over 3000. So this is one equation with two unknowns I can solve. Let's say for b, let's see, this is 100, 150 minus 100 gives me 50, equal to this 100 knocks off 20, the 1000 here knocks off 30, so I have 50 equal to, let's see, b over 20 minus c over 3. If I multiply both sides by 20, I have 1000 equal to b minus 23rd of c. Therefore, b turns out to be 1000 plus 23rd of c. Now, if I use the other initial condition, which says during 10 seconds it travels 700 meters, then I can use equation 2 and write s of 10, which is equal to 700 equals to, I want to plug 10 seconds in the right side of equation 2, which gives me, let's see, 5 times 10 squared plus b 10 cube over 6000 minus c 10 to the 4th power over 12,000. Let's simplify this equation and proceed to finish the algebra. Then let's see, I have 500 here, 700 there. This gives me 200 equals to, now this is 1,000. I can get rid of the 3 zeros there. This is 10,000, so I can write this as, let's write it down. And so I have 200 equal to b over 6 minus, I can have, let's see, 10 over 12. Observe that 10 to the 4th power has 4 zeros. I have 3 zeros in the denominator, so I'm looking at 10 over 12, which is 5/6 of C. So I can solve this equation. Let's see, if I multiply both sides by 6, I'll have an easier version of it. 6 times 200 is 1200 equals to B minus 5C. But I already found B right here, so I can plug it in there and solve for C. Well, let's first solve this B. I want to go back to my pointer here. So let's say B equals to, if I solve this equation for B equals to 1200 plus 5C. But over here I have 1000. For B I have 1000 plus equals to 20 thirds of C. This is B. I can let it equal to the other B up here, which is 1200 plus 5C. So I have one equation, one unknown. I can solve this for C. Doing the algebra, I promise you to get C equal to 120 if you take a calculator and solve this last equation. And finally, now that I have C, I want to multiply it by 5 and plug it in here. 120 times 5 is 600, and 1200, that should give me a B of 1800. So let's write B, let's write B equal to 1800. So now I have the constants. Therefore the propulsive force, if I write it as a quadratic function of time, is going to be F equal to 10,000, remember that was cap A, plus B, which is 1800 T minus 120 T squared. So this is how the propulsive force acts on the, what am I doing? Okay. Alright, thanks for watching.